Hi folks, we're going to take a look at a word problem here. So let's take a look at it. We have the sum of the height and twice the base of a triangle is equal to 12. Find the largest such triangle in terms of the area. Okay, so the first thing I want you to do when you look at a word problem is see if you can figure out, before even starting, what procedure you're going to be using. And here I see that the key word is the largest such triangle. So anything we're looking for, maximum, minimum, largest, smallest, you should be thinking, I'm going to need to complete the square on a quadratic most likely. Okay, and here the largest what? Well, largest triangle, but in terms of area. So what I'm looking for is the largest area. So keep in mind that this is what we're hoping to find at the end. Okay, so the first thing here is to look at what information they give us about the important components of a triangle. And we know the important components of a triangle in terms of area are the base and the height, because that's what we use to find the area. So let's see if we can take this line here and translate it into an equation. So here they're saying the sum, so I'm going to be adding two things, of the height. So I'm adding the height plus twice the base. Okay, and that has to be equal to 12. Okay, so I write down my equation, but I also need to indicate what these variables represent. So here I should indicate that the height is equal to h, so height of triangle, and here the b will represent the base of the triangle. Okay, now this is the relationship between those two dimensions, but what I'm interested in finding is the largest area. So this is where we recall what the area of a triangle is given by. It's given by 1/2 base times height. Okay, and as we've seen in pretty much every one of these problems, I want to find the maximum area, but the equation is given using these two different variables. Okay, and what we're going to do is perform a substitution. So what I want to do is substitute one of these variables. So I go back to my equation with base and height, and I try to determine which one of these is easier to isolate. And in this case here, because the coefficient of h is 1, that's clearly the easier one to isolate. So that's what I'm going to do. I'm going to write h equals, and I'm going to bring this plus 2b to the other side of the equation. So it's going to become minus 2b, and then of course I've got the plus 12. So this is what I'm going to use to do my substitution. So in this equation here, wherever I see an h, I'm going to replace it by negative 2b plus 12. So negative 2b plus 12. And now I have a function that has only one type of variable. Okay, so let's now go ahead and solve that. So first thing we have to do is let's put it in standard form. Okay, so here we've got 1/2 b times negative 2b. So again, you might be able to do that in your head, or maybe you need to use a calculator. Either way is fine. So let's see what we have here. We have 1/2, which is 0.5 times negative 2. Okay, that's negative 1. Okay, so here we have negative, don't forget the b's here are squared, because there's two of them. And then I'm going to multiply 1/2 times 12. Well, that I think I do in my head. Half of 12 is equal to 6. So plus 6, and don't forget the b there. Okay, and here we have a quadratic function in standard form. Okay, and since we're looking for a maximum area, the procedure we're going to use here is to complete the square. So as usual, our first step in completing the square is to factor out whatever numbers in front of the squared value. And so here it's a negative 1, so I'm going to factor out that negative 1. I'm left with b squared, and here 6 divided by negative 1 is negative 6. Okay, once I've done that, with the expression in the bracket, I can now complete the square. So this we've done many times before. Minus 6b, I have to add and subtract half of this number squared. So 6 divided by 2 is 3. So I add 3 squared, subtract 3 squared. Okay, let's continue here. The first 3 terms are what always factor to my perfect square. In this case here, it's b minus, because of that subtraction up here, so b minus the number I've squared, so 3 squared, and then I'm left with the minus 9, and now I just have to simplify to get it in vertex form. So I'm going to I'm going to distribute the negative 1. So negative 1 times the first term in the expression at b minus 3 squared, and then negative 1 times negative 9 is going to be positive 9. Okay, and so now we have it in vertex form. So I go back to my question, and what do they want? The largest area. So the area here is like my y value, and so that maximum value is found right there, our k value of 9. So the maximum area is 9. Okay, and here they didn't give us any units, so we can say units squared. Had they given me centimeters, I would have used centimeters squared. If it was meters, I would have used meters squared. Now I'm going to add a question in here that I didn't put in the original one. Let's say they were asking us to find the dimensions of this triangle. What are the dimensions? Okay, so the dimensions of a triangle are the base and the height, those two things that we use to determine the area. So one of those I can get in the equation. Okay, what is the base that gives me my maximum height? Well, that's found inside my bracket. Okay, so here the base we know is going to be equal to 3 units. Now I need to find my height, but let's remember what I had done originally up here, and this is similar again to substitution when you were solving a system of equations. I can now use this equation here to find the height. So the height is equal to negative 2b plus 12. Okay, but here now I know my b value is 3, so 2 times 3 plus 12, and let's stick that in our calculator. Negative 2 times 3 plus 12 is equal to 6. Okay, so there we have it. The dimensions of the triangle that give us, oh, there we go, sorry about that, that give us the maximum area is a base of 3 and a height of 6, and the actual maximum area is 9. So let's just do a review on how to solve these questions. So the first thing you notice is there's no equation in this question, meaning you're going to have to come up with it. But even before we do that, we realize that we see the word largest, so that indicates that we're probably going to complete the square. And step 1 was to write a relationship between the two unknowns, in this case here, height and base, and then come up with a function to represent what we want to find the maximum value of, in this case here, area. Write our equation, and then do a substitution in order to get a function of only one variable. In this case here, the variable we used was the base. Go through the procedure of completing the square, and then once you've done that, make sure you answer the question that was posed. Okay, that's it for now.